Good morning to you children. Mathematics is the queen of sciences. Why is it said so? Mathematics plays a very important role in all subjects. If you take any of your core subjects, you can see its application either in a brief way or an elaborate way. In our daily lives too, the applications are very high. That is why the subject mathematics have many branches, in which a few of them have been introduced to you in your previous classes, like arithmetic, which deals with numbers, algebra, which deals with numbers and letters, geometry, which deals with a position which represents a point, and a point moving in a path, giving you line segments, figures, solids, and so on. Similarly, statistics, which deals with data handling, mensuration, which deals with volume occupied by solids, then commercial maths, which deals with profit, loss, simple interest, and so on. Many more branches will be taught to you in your higher classes. The first lesson in Standard 8 deals with rational numbers, or it belongs to the number system. The numbers which we use to count 1, 2, 3, etc. are called natural or counting numbers. With the inclusion of 0, the set of numbers 0, 1, 2, 3, etc. is named as whole numbers, and any natural number or whole number will be represented on a number line, and there were numbers below 0 by which you were introduced to the set of integers with negative numbers, that is numbers below 0, and as a continuation from integers, you were introduced with numbers of the form p by q, where p and q are integers, q not equal to 0, and such numbers of the form p by q were called as rational numbers. Thus, in short, we can say the number system started with counting numbers, which got extended to whole numbers, then to integers, and then into rational numbers, which are in the form of p by q, where p and q are integers and q not equal to 0. The first topic in your lesson is to check certain properties like closure property, commutative property, associative property, rule of 0 and rule of 1 is satisfied or not satisfied by the numbers natural numbers, whole numbers, integers, and p by and rational numbers. How can you justify whether the properties are satisfied is by the help of the 4 fundamental operations in maths as addition, subtraction, multiplication, and division. With the help of the examples, you will understand the concept very well. Let's take the first set of numbers as natural numbers. The first property of closure property for natural numbers. That is, we have to prove whether addition of natural numbers satisfies closure property, subtraction, multiplication and division of natural numbers satisfies the closure property. The meaning is, under addition, let us take two numbers, two natural numbers as 5 and 6. 5 plus 6, the answer is 11, and 11 also belongs to the set of natural numbers. So what will be the information, or what will be the justification is, whole natural numbers are closed under addition. That is, addition satisfies closure property. If the addition answer or the sum is also a natural number, we can say that the property is satisfied. Let's go with the second operation of subtraction. We can use the same numbers as 5 and 6 because both of them are natural numbers. 5 minus 6, the answer is -1. Is -1 belonging to the set of natural numbers? No, it is an integer. So we can say natural numbers are not closed under subtraction. Even if 6 minus 5 equal to 1 is a natural number, there are cases like 5 minus 6 and it is not always closed under subtraction. So we are generalizing it as natural numbers are not closed under subtraction. What about multiplication? The two natural numbers are 5 and 6. 5 into 6 is 30. Again, it is also a natural number, or natural numbers are closed under multiplication. And what about division? 5 divided by 6, 5 by 6 is a fraction, and it is not a natural number, which shows that natural numbers are not closed under division. This is the pattern of checking whether a property is satisfied by natural numbers by application of addition, subtraction, multiplication and division. Closure property for whole numbers. Whole numbers includes an element of 0, but remaining all are natural numbers. If a property has to be satisfied, it should be uniformly satisfied by all the members of the set. Let's go with example with 0, addition 0 plus 6, 6, which is a natural number, hence natural numbers are, which is a whole number. Whole numbers are closed under addition. What about subtraction? Let's take the same example of 0 minus 6, negative 6. Whole numbers are not closed under subtraction. What about 0 into 6 is the same as 0. It's a whole number. Again, whole numbers are closed under multiplication. If you take 0 divided by 6, the answer is 0, a whole number. But Whole number system includes other numbers too. Let me take the example of 1 and 6. 1 divided by 6 is not a whole number. That is, in general, whole numbers are not closed under division. The same rule for natural numbers and whole numbers, that is, addition and multiplication will be satisfied in the case of natural numbers and whole numbers, but subtraction and division do not satisfy closure property for whole numbers and natural numbers. Checking the first property, closure property, for the third set of numbers, integers. Addition of integers. Even let's take two positive integers as 6 and 3. Answer is 9. Two negative integers minus 3 and minus 7, minus 10. Is the sum also an integer? Yes, that is also an integer. Thus you can see that integers are closed under addition. That means if you add two integers, the resulting answer is also an integer, which proves that integers are closed under addition, means the closure property is satisfied. What about subtraction of integers? How many examples, however you take, minus 5, minus 3, 3 minus 5. You can see it is minus 8, 3 minus 5 is negative 2. All are again integers, which shows that integers are closed under subtraction also. That means integers follow closure property for subtraction also. Multiplication, what is 5 into 3? 15, an integer. What is minus 5 into 3? Minus 15, an integer. Or what is minus 5 into minus 3? Positive 15, again an integer, which shows that integers are closed under multiplication also. Division. For division, minus 16 divided by 4 is minus 4. Minus 16 divided by minus 4 is equal to positive 4. Minus 16 divided by 3 is minus 16 by 3. Is it an integer? No. Even though there are integers in division, all integers when you divide with one another, the answer may not be an integer. That is why integers are not closed under division, or closure property is not satisfied for division of integers. The fourth set of numbers, rational numbers. We have to check whether addition of rational numbers, subtraction of rational numbers, multiplication and division of rational numbers follow closure property. Before doing addition of rational numbers, let me make it very clear to you that if the rational number involves denominators, LCM is an important concept in addition and subtraction. Two rational numbers can be added or subtracted only by taking LCM. The first concept of addition. Let us take two rational numbers of unlike sign, minus 7 by 8 and 3 by 2. Addition. How do you add? Minus 7 by 8 plus 3 by 2. Addition of rational numbers, since the denominators are unlike, the LCM of 8 and 2 is 2, 2, 2, 1. Or since 8 is a multiple, LCM of 2 and 8 is 8. LCM is 2 into 2 into 2, 8. That means 8 is the LCM. Into 1 is minus 7. Into 4 is 12. 12 minus 7 is 5 by 8. Is 5 by 8 also a rational number? Yes. 5 by 8 is a rational number. So how can you give the justification as rational numbers are closed under addition? That means rational numbers strictly follow closure property for addition. Let's take subtraction. Subtraction as minus 5 by 6 and 7 by 4. Minus 5 by 6 minus 7 by 4. The same way 4 and 6 are, unlike denominators, LCM of 4 and 6 are 2, 1, 3, 3, 1. That is 2 into 2, 4 into 3, 12. How do you convert? As 12 into 2 is giving you minus 10. Into 3 is giving you minus 21. How do you subtract integers? Integers are subtracted by converting them into addition, that is by the inverse process. Change subtraction into addition, at the same time you are changing the sign of the second number. That means you are adding the inverse of the second integer. The answer is minus 31 by 12. Is it a rational number? Yes, it is also a rational number, which proves that rational numbers are closed under subtraction also. What about the third operation of multiplication? Multiplication of two rational numbers. Minus 5 by 6 and 7 by 3. How do you multiply? Minus 5 by 6 into 7 by 3. For multiplication, you can simplify. 3 and 5 will not get simplified. 3 and 7 will not get simplified. Even 6 and 5, 6 and 7, that is, the product is minus 35 by 18. Is minus 35 by 18 a rational number? Yes, it is a rational number, which shows that the property rational number is closed under multiplication also. The division process, division. Minus 11 by 2 and 7 by 8. How do you divide rational numbers? Minus 11 by 2 divided by 7 by 8. Minus 11 by 2 into 8 by 7. Like subtraction, you are doing addition with the inverse. Division, you are converting into multiplication by the reciprocal or multiplicative inverse. The answer is 2 and 8 can be cancelled, or minus 44 by 7. Is minus 44 by 7 a rational number? Yes. But 0 is a rational number because 0 can be expressed of the form 0 divided by 1. That is, the rational number is any number of the form p by q where p and q are integers. What about you are dividing a rational number minus 11 by 2 with 0? Minus 11 by 2 is a rational number. 0 is a rational number. Division by 0 is not defined. It is not defined, which proves that if a rational number 0 is taken as divisor, the rational numbers are not closed. Rational numbers are not closed under division. Even though all the other rational numbers satisfies, the number 0 is a rational number, and since division by 0 is not defined, rational numbers are not closed under division. The second property which needs to be checked is the commutative property, which we call it as we are checking the commutativity of numbers. The meaning is you can change the order of the numbers in the particular operation. That is, if A and B are two numbers, if under addition, if A plus B and B plus A are equal, we can say that numbers follow commutative property. If A minus B and B minus A are equal, we can say the system of numbers follow commutative property under subtraction. Similarly, if A into B and B into A are equal, A divided by B and B divided by A are equal, we can say that the numbers follow commutative property under that particular operation in maths. Let's start with the first set of numbers. The first set of numbers, natural numbers, and see whether the four properties of the four operations of addition, subtraction, multiplication and division gives you the answer. Let the two natural numbers be 10 and 12. 10 plus 12 is 22. 12 plus 10 is also 22. Thus, you can say addition of natural numbers is commutative, or natural numbers is commutative in addition. The second subtraction, let it be any number as 23 and 6. 23 minus 6 is 17. 6 minus 23 is negative 17. Are they equal? No. Therefore, you can say subtraction of natural numbers is not commutative. The third concept is multiplication of two natural numbers as 10 and 5. 10 into 5 is 50. 5 into 10 also 50. Therefore, multiplication is commutative, or multiplication of natural numbers, multiplication is commutative. What about division? the two numbers 12 and 5. 12 divided by 5 will give you 2.4, whereas 5 divided by 12 is giving you 0.4, etc., which shows that the answers are not same. That is, division is not commutative for natural numbers. That is, we are defining for the set of natural numbers. Similarly, by including 0, you can verify the rules for whole numbers. Let's pass on to integers. Any two integers as -1 and 2. -1 plus 2 is giving you +1, and 2 plus -1 is also giving you +1, which shows that addition is commutative in case of integers. Subtraction 3 and -4. You have to subtract 3 minus -4, -4 minus 3. Subtraction, addition with the inverse, addition with the inverse. Integers of like sign will be added and given the common sign. Integers of like sign will be added and given the common sign, but the answers are not same. What will you say? Subtraction is not commutative in case of integers. The third operation is multiplication with the integers 5 and -6. 5 into -6 is -30, and -6 into 5 also -30. Since the answers are same, multiplication is commutative for integers. The fourth operation of division, -6 divided by, let the integers be -6 and 2. -6 divided by 2 is -3. 2 divided by -6 is -1 by 3. They are not equal, which shows that division is not commutative for integers. So these are the property explanation for the set of integers. The commutative property for rational numbers for addition, subtraction, multiplication and division. Addition of rational numbers. Let the rational numbers be 3 by 5 and -1 by 2. What we are supposed to get is the answer for 3 by 5 plus -1 by 2 and -1 by 2 plus 3 by 5. The commutative property means the interchange of numbers should give the same answer. Addition of rational numbers with unlike denominator. LCM of 2 and 5 is 10. Into 2 will give you 6 by 10. Into 5 will give you -5 by 10. 6 plus -5 by 10 is giving you 1 by 10. Similarly, into 5 is -5. Into 2 is 6 by 10. The same answer of 1 by 10. So what can you justify is addition of rational numbers is commutative or rational numbers satisfy commutative property under addition. Subtraction of rational numbers. Two rational numbers as 3 by 4 and 7 by 9. 3 by 4 minus 7 by 9, 7 by 9 minus 3 by 4. Check the answers. 4 and 9, LCM will be 36 since they do not have any common factor. 4 into 9, 27 minus 9 into 4, 28 by 36, or it is minus 1 by 36. 9 into 4 into 4 into 9 into 9 is 28 minus 27 by 36, or positive 1 by 36. They are not equal. That means subtraction of rational numbers is not commutative, or in other words, commutative property is not satisfied for rational numbers under subtraction. Let's check with two rational numbers for multiplication and division. The two rational numbers as minus 1 by 8 and 5. Minus 1 by 8 into 5, 5 into minus 1 by 8 should give the same answers if you have to follow commutative property. Minus 5 by 8, since it cannot be simplified, here also minus 5 by 8. So what is the property is multiplication is commutative for rational numbers, or rational numbers possess the property of commutative property for under multiplication. What about division? Let's take the numbers of 1 by 2 and minus 1 by 3. 1 by 2 divided by minus 1 by 3. 1 by 2 into minus 3 by 1, or minus 3 by 2. Minus 1 by 3 and 1 by 2. Minus 1 by 3 divided by 1 by 2. Minus 1 by 3 into 2 by 1 is minus 2 by 3. Are they same? No. So what is the property? Division is not commutative for the set of rational numbers, or rational numbers do not satisfy commutative property for under division.